So here we go. Welcome to this presentation, Ericsson Industry Connect, a case study for SUSE Linux Enterprise and Kubernetes at the edge. The edge. What is the edge? I found one definition that says edge is a mesh network of micro data centers that process or store critical data locally and push all received data to a central data center or cloud storage repository in a footprint of less than 100 square feet. So that's roughly 3 by 3 meters or so. And that's from IDC. So less than 100 square feet, is this really the best definition for edge? Well, we thought about it. And I think in today's case study that Georg Schmücking from Ericsson is going to present to us, we will find, sorry, yeah, go on, Eric.
Together with Joachim Werner from SUSE, who's the principal product manager.
Right, so together we will guide you through some of the critical problems that you will be facing when you deploy software and hardware at the edge and how these can be solved in real life. In a nutshell, I'll spend a few minutes talking about SUSE and our portfolio and the challenges for deploying at the edge. And then Georg will present the actual case study about Ericsson Industry Connect. And finally, I will dive a bit into the roadmap of the SUSE Edge strategy and portfolio. So SUSE is much more than Linux. You may have heard about us as the provider of a Linux OS. And actually for the last 28 years, we have been one of the leaders in true open source. But recently, we have broadened our portfolio in terms of managing infrastructure, software, and just a couple of months ago, we announced the intent to acquire Rancher Labs, which will be a further completion of our portfolio. The portfolio has still Linux Enterprise Server and Linux in the center of everything. But as you can see, there's so many other products and solutions around the full portfolio of software-defined infrastructure, container and cloud platform, but also edge computing. We've been doing edge computing scenarios long before that name exists in industries like telecom, like medical care, retail, and so on. And today we'll have a use case from the telecommunications industry that Georg is going to present in a minute. So I don't want to bore you with all those success numbers, but I just picked two. So the top 10 of the largest telecommunications carriers are using SUSE Linux, and also 7 out of 10 manufacturers. And this use case, as you'll see, is a use case that combines the two because it's about having cellular networks on the factory floor. Now, let's look a bit into the typical challenges at the edge that we think help you define what an edge strategy should be and how an edge product needs to be designed. So what really matters at the edge? First of all, in many cases, and Georg will be able to prove this later, you will not have a full-time IT staff on site. Remote management is a must. The systems may not even be set up by your own people, your own engineers, but you may have to rely on the customer to set it up, or a logistics contractor who's basically just familiar with plugging in the cables. It could be large-scale deployments, hundreds or thousands or tens of thousands of devices worldwide. So it can be just, you know, a scalability issue if you want to do this all more or less manually. And in many cases, you need to preload the software already in the factory, which then sometimes means that by the time the box hits the customer or the logistics contractor, it may already be outdated when it's connected the first time. So as we can see, edge can be pretty hard. From the initial deployment, either in the factory or on site, let's say from a USB thumb drive or a media, to establishing the initial trust, a box that just came in a package delivered by UPS or the post office, and then you have to trust it one way or the other because it will most likely connect to some internet infrastructure. You need to configure it. It could be like a more general purpose device, and you need to configure it depending on what the customer bought it for. And then, of course, over the lifetime, you need lifecycle management for changing, patching, and updating, and of course, monitoring. So without further ado, I'll hand over now to Georg, who is going to lead us through the actual case study of Ericsson Industry Connect.
Thank you very much, Joachim. Let me first of all say just a couple of words about Ericsson. We are the world leader in ICT and 5G for cellular networks. We are able to address all our customers, mainly mobile network operators, in over 180 countries by having offices and with in total around 100,000 employees, so that we are right at the edge where all our customers are and where their problems are. We have 4 pillars in Ericsson where our business is. The first pillar where we have a lot of our products is networks. This has everything from antennas, radios, through all the necessary tools, software, and products to connect any clients to the cellular network and build up the cellular network. Digital services then gives you all the different tools and software in order to operate your cellular network and operate your business. With managed services, we are not only able to design and deploy, but even if our customers want to operate their complete networks. And our last part, the technology and new businesses unit, we are looking into all the new solutions, all the new technologies out there. For example, IoT or now the 5G story. Okay, what is our Ericsson Dedicated Network Industry Connect product? It is actually a very, very small form factor standalone network. That means our customers can build up their complete own network with this product. As you can see in the black box, it is roughly 4 to 5 units high and can fit into a normal networking cabinet. With that, you're able to set up your own cellular network where you can connect all your different cellular devices directly and directly have the traffic go to your own network on the factory floor. In order to make the build and also the maintenance of cellular networks easy for our customers, we have done a great deal to automate all the different processes. From the installation, which can from one button push take automatically 1 hour until the network is active, to all the other different tasks which needs to be done by our customers to maintain and configure their own personal cellular network. Furthermore, we are very active in the ecosystem, in the environment, to help all the different vendors of different devices so that they are pre-integrated, pre-certified, so that our customers in the end have a lot of different devices available, which they can very easily plug and play into their own network. Why do we think that enterprises need or would want cellular networks? They have several different advantages. For example, we have with cellular networks, we have very reliable and low latency networks, so that our customers would be able to, for example, connect robots or other machines which need a very reliable connection and where real-time monitoring with low latencies is necessary. We are also able, with all the different cellular network antennas, to have a very flexible deployment. so that you can either have one factory floor, your complete factory, or even the complete campus covered by the cellular network. With the very well-known security technologies like SIM cards, we're able to secure the network so that only devices you actually want to have in your network can connect. And as I already said, we are working with the ecosystem to make sure that there are a lot of different devices available so that you can have all the needs covered by different devices in a plug-and-play fashion. With 5G, all those different values will actually even increase. For example, not only can, for example, the data rates, the peak data rates down and upstream will increase a lot, up to even several tens of gigabits per second. So that not only can you stream certain monitoring data, but you can actually even stream complete video streams, for example. Furthermore, the low latency requirements of, for example, 1 millisecond are so low that you can even have advanced augmented reality applications where humans normally get very dizzy if they have too high latencies. This can help, for example, with maintenance tasks. And of course, things like the availability and reliability makes cellular networks a very viable solution to connect moving or even fixed parts on the factory floor. How have we set up our Ericsson Industry Connect product? First of all, like we have heard from Joachim already, one big part is the maintenance if you deploy such systems into the edge. And when we deploy a system, we have two different parts. On the left hand, we have the network controllers, and then next to that, we actually have the radio systems. And in order to support hundreds, thousands, 10,000s, and even more systems, all those systems connect actually to a cloud-based management system so that we can remotely manage and configure those systems. When such a system is actually deployed to a customer, it will come with a preloaded image of SUSE Linux Enterprise Server and a VPN client and a Salt minion on that. This enables us, by connecting to the cloud-based management, to automatically then install all the necessary applications, like we have a Kubernetes environment and all the applications which are necessary to build up the cellular network. What is Salt? Salt is a remote execution and configuration management tool. So it gives us the possibility to install automatically and maintain all the different applications and the Kubernetes environment, but also execute certain tasks to either configure things for the customer or to have the complete maintenance and lifecycle management. Furthermore, it is built on an event framework. So we don't only can just monitor the system, but the system actually monitors itself. And with Salt, we are able to react on those events automatically if they appear. Together with the SUSE Linux Enterprise Server, we are also able with Salt to actually upgrade all different components, including the operating system, completely remotely. That's why we use Salt as our complete lifecycle management for all our systems in Industry Connect. And like I said already, we actually, from the base image, we actually install all other components remotely through Salt. We have chosen to actually use containers and Kubernetes for a lot of different options, for a lot of different reasons. First of all, containers provide a very easy way to lifecycle manage an application. You can very easily start it, stop it, remove it, install it, and also upgrade to a new version. Furthermore, Kubernetes gives you the possibility to deploy not just one application, but a complete set of applications and directly bundle those with a configuration. On top of that, it has built-in capabilities to provide logging, fault management, and other common tasks you need to make sure your applications are always running. For the overall system, we had a couple other technical considerations. First of all, we need to have all the systems combined into the cloud backends in order to maintain them in a reliable way and in a scalable way, but also in order to support different regions over all the globe, we actually need to have several different. Since we are delivering the servers with a pre-installed image, which is the same for all the different customers, we need to then choose at the customer side to which cloud backend the customer should, the system of the customer should connect. Furthermore, one of the big issues is also that, of course, you might have an old image delivered to the customer. So we need to recognize all those things and be able to handle them before we can go on to install the complete system. That's why we have developed a DMZ process to facilitate those troubles and problems at the edge and to enhance the trust we can have in our systems. The DMZ consists of a salt master, which is one of our lifecycle managers, and a VPN server, and the cloud-based management, of course, as well. So when a system is delivered at the customer side, it automatically connects to our DMZ. This makes it then possible for us to install a new image if necessary, but also do other tests and configurations right away so that we can update the system to the needed version or to ensure that the system actually is trusted by us. Then the customer itself can start the installation process through a management portal, which will then, through our lifecycle management, enable us to automatically move the system over into our cloud-based management after we, of course, have trusted it now. And from there, we can then start all the installation process to install Kubernetes, to install the applications, so that the customer, with one button push, can have their own cellular network. And all the other maintenance and configuration tasks, both from our side as well as from the side of the customers, will also go through the lifecycle management through the VPN tunnel to this system. With that, I hand over to Joachim again so that he can explain a little bit more what SUSE can actually do.
So thank you so much, Georg. I think this was a really interesting case study, not only because it's about an edge device itself, but the whole use case brings edge connectivity to the factory floor and enables other edge devices like sensors, like, as you mentioned, the virtual reality use cases and all those, augmented reality. So without further ado, one of the things that we are going to provide to make the life of partners like Ericsson easier is that we are going to release an operating system flavor that is really targeted towards edge use cases. It's going to be called SUSE Microwaves, and we are planning to ship it latest by Q2 2021 next year. It will come with a minimal footprint. It is based on the trusted SUSE enterprise code base, but as I said, designed for edge use cases. Among other things, it will already come into architecture flavors, so Intel AMD and ARM 64-bit. It will be an immutable OS, so the actual OS is mounted read-only, and when we do updates, we actually do them in the background in a file system snapshot. So we can later, basically by rebooting, go into the updated version. And also there's an integrated health check. So if something goes wrong, which shouldn't happen, but if it still happens, we can easily roll back the system to the last known good state. The containers that we are going to run on that platform, because yes, we've learned from that use case, and we are going to provide a framework that can run containers and also VMs on top of this hardened platform. Those are protected with SE Linux, so the containment is even better than with just plain containers or plain VMs. There is a secure update infrastructure. So if you don't want to basically build your own update infrastructure for the OS parts of the solution, you can also rely on SUSE's SUSE Customer Center infrastructure and basically use our hosted infrastructure for that. And the updates are really small. It's not like you have to always push a whole new image, but we can do really small Delta updates for, let's say, a security patch or so. And as I've mentioned, the technology stack using those file system snapshots also makes it really easy to recover from a faulty update or any other fault condition in the OS. And this will not end up trying again and again. So after some time, after a couple of tries, we will also then at some point decide, okay, the system cannot be recovered because maybe it's really a hardware problem, and shut down gracefully. The workloads will be running clearly separated in dedicated containers. And this also even means that if you have to do maintenance tasks on the machine that would usually require to log in on an SSH shell or something like that, even those tools will be in a toolbox container, and the toolbox container will have state, so it can install extra software that you need if necessary. This is very neat for debugging these systems before they actually go into production. But then after you've done your maintenance, this container can be discarded, and a fresh one can be started next time you need it. The deployment will be really easy, both for scenarios where you have to do factory preloads, as in the Ericsson example, and also if you have to do this later. Just like in Ericsson's case, we'll already ship with all the automation necessary. The Salt stack is already pre-installed, so you can plug into a Salt management framework as well. There is an optional web-based management console. Not everyone is going to need this, but this is a very easy way of having a headless device where if you want to, let's say, change some of the network parameters or so, you can basically log in over a web browser and access the device from there. Yeah, I've already mentioned that Salt and preparation for connecting to our SUSE Manager management framework are already built in. Yeah. This is again a picture that shows how those layers will work. Updates can come directly from SUSE Customer Center. In many cases, what we will expect is that the actual device manufacturer may maintain their own applications as containers, but rely on SUSE to provide the standard updates for the operating system. But you can, of course, also choose to manage the whole stack from your own update infrastructure. Yeah, the workloads are clearly separated, and as I've mentioned, we also will offer a variety of microOS that allows you to run full VMs. There are a few integration improvements with the Salt management stack. First of all, something that we've already started a few years ago, Salt now allows you to send a serial number, a unique ID, or even a certificate that has been put onto the TPM chip or so of that device. Or sometimes you have devices that have so-called eFuses, where you can basically write once into a flash. And then we can use that for authentication purposes. So when the device hits the management server for the first time, we can really verify whether that's a legit device. We've also added Redfish support. This is an ongoing effort together with a hardware partner. Redfish is a more standardized protocol for managing hardware through, in most cases, a management board controller, a REST-based protocol. This will allow you to even recover from situations where the OS itself is down, because you can still reach that management board controller and, for example, check whether there are hardware issues. Maybe a fan is broken, or a disk is broken, or the RAID has a problem. And finally, with Yomi, we are introducing a new way of bare metal installation that is entirely Salt-based. So you won't need to switch between the tools you need for installing the initial OS, let's say AutoYast or Kickstart or tools like that. And then finally, once the OS is installed, Salt to manage the configuration. You can do all this from Salt. Yomi starts in RAM and can then completely prepare a machine This also allows scenarios where a single image is used and can adapt very nicely to different situations, like extra disks or stuff like that. Because we will connect to Salt very early on, the management server can already make decisions. So basically already analyze the system and say, this is the big one, or this is the small one. Okay, I'll send different instructions for the initial installation and partitioning. Finally, looking at those scenarios, we've been thinking about building something that's very close to the open network infrastructure environment that you, open network installation environment that you may know if you are familiar with network gear. This is basically a mini Linux that comes pre-installed and that allows you to install the actual operating system or firmware on those network devices. And we think that in a very similar way, we could ship devices that are basically generic, that don't have a personality yet, with a built-in Yomi installer, and then basically allow a management server to take over and do the full configuration and customization. So before I come to the end, just very briefly, I want to talk a bit about the options that you have for managing the containers in such a micro-OS environment. This starts with a very basic tool. Systemd is basically what starts all your services on a modern Linux system. And Systemd these days can also start containers and full-fledged so-called OCI bundles, so with all the container metadata. But it's really meant for starting individual containers. There's no orchestration or so yet. Then the next stage is Podman. This already reads full Kubernetes manifests and can say, okay, this is a set of pods that I need to install. And pod is basically applications that are containerized and that belong together. Then there's K3S, which is a fully certified Kubernetes distribution, but really lightweight. So it only has like half of the memory footprint of a full Kubernetes. So it's ideal for IoT and edge scenarios. It's also very easy to install because it comes as a single binary. And finally, of course, for some scenarios, you'll still want full Kubernetes, where you have all the features for HA, for large clusters, multi-node clusters, and so on. So we will have the right choice of container management options for you, and those will also integrate nicely into the management tool stack, of course. Yeah, if you want to know more about our edge products and strategies, there's a landing page on SUSE.com and also a white paper you can download. And that brings me to the end of the talk. And again, I want to say thank you to Georg for this really insightful use case that he presented with us. And I'm sure you can always follow up on social media and so on and talk to us if you have more questions about this.